Hello everyone, welcome back to my channel. Today let's go over a medium linked list question that I solved around half a year ago. So let's try to redo it. So you're given the head of a linked list, and basically what you want to do is between every two nodes, insert the greatest common denominator between these two nodes. So this pair, this pair, this pair. First and second and third and fourth. Okay. So every pair overlapping with every one that's not the last one and not the first one. So then you just want to return that linked list after the insertion. So pretty straightforward. Let's go ahead and get all the nodes of the linked list into an array as usual. Cur.append head.val head equals head.next. Print current. Now we should have an integer array instead of a linked list object. And then now let's go through every pair. So for I in range 1 to length of cur, going from this and then comparing to the previous, and then this, previous, this, comparing to 10, and then we're done. So let's say what we need is math.gcd between the previous node 18 and the current node 6, and then let's make an array called answer so we can turn it back into a linked list. Answer.append need, let's print answer. Okay, so we want to, I guess, answer is cur.copy, answer.insert at I need, right? Because we want to insert it in between. Okay. Say previous and GCD. That's very odd. Print I answer. So we're going to need to insert at index 1, index 2, and index 3. So 1, 2, and 3, right? So that's why we're going to make a copy so we don't mess up the current node as we're inside of it. Copy.insert at I need. Let's print our copy, because if we mess up current, then we're not going to have a copy. So I don't know why this is. Let's call this previous, and now is cur I minus 1 and current of I. Let's print previous and now. Yes. Between. Oh, we're overriding it. That's a pain, because need print current so you can see. So we're going to insert 6 and then 2 and then 1, but we don't want to get rid of the current 6. So let's print I. Let's make a dictionary. di equals need. Let's print d. So this is basically telling us where everything needs to go. So for K and D, Cur dot insert at index k, the value print current. You're still overriding the values, and that's the problem. We want to add and not append. Or we want to add and we don't want to delete. That's the problem. Oh, man. Okay. Okay, what we're going to do is actually just 0 and then 1 and then append whatever's next. So basically, so for I in range length cur, if I is not in D, then we're just going to append cur of I, else answer dot append D of K or D of I, and then answer dot append cur of I. For answer, okay, D of I. Oh, we don't need this. Okay, cool. Yeah, so this makes sure that when we insert at index 1, we don't just get rid of this, we add another one and then shift this to the right by 1. So now this original 6 is at index 2. Okay, and then looks like we can just turn this back into a linked list. So the rest is pretty straightforward. Dummy equals list node, cur equals dummy, turn this integer array back to a linked list. For a and answer, cur.next equals list node of a, cur equals cur.next, return dummy.next. And there you go, passes all test cases. So again, not the most efficient, but I did come up with this on my own. As you can see, I struggled a little bit, but I was able to do it, so I'm pretty proud of that. Thank you for watching this video, and stay tuned for more.